Okay, everyone, so we've been evaluating logarithms. Let's do some examples here. So what we're going to do here is we're going to rewrite the following in exponential form. So if we recall, I know that 3 is the base. And so if 3 is the base, I'm going to make sure that it stays as the base. All right, so my logarithm, again, base 3. Keep the base, it is the base, it stays down here low. And then I'm going to make, well, 2 is on this side of the equal sign, so I'm going to put it with a 2. And then 9 goes on the other side of the equal sign, and so this is what this says here. Log base 3, 2 equals 9. When we go to this one, now, oh, there's no base here. When there's no base, it's a special one. It's called a common logarithm. It's implied there's a 10 as a subscript. And if you look at your calculator, this button here, log, it assumes, it's one of the most common logarithms. There's a base 10 there as well. So there's a base 10. It's happened so often we don't even write it. So if I'm going to change this, I know it's going to be my base to the exponent 3 is equal to 10,000 or 1,000. All right. You should pause the video and try this one on your own. Okay, great. Now that you're back, again, I'm going to start with the base, which is p. Here's my base, and so p to the exponent t, because it is equal to q. And so you have to be able to rearrange these logarithms quite simply. All right. Similarly, I'm going to go the other direction now. Well, I know that 25 to the 1/2 is 5. That's a true statement, because that's the square root of 25. But if I'm going to write it as a logarithm, so I start with the logarithm, I make the base the base. The base is 25. So 25, well, these were connected before I separate them. I'm going to be 5 is equal to 1/2. And so this is going from an exponential to logarithm. Okay, so now we're going to evaluate these out of a calculator. So what we're going to do, we can check with our calculator. I'm going to take, I'll make it a little bit bigger maybe. So if I take this, I know log base 3, 81. And so what I can do, I'm going to call this x. I'm going to do this 2 different ways. I'll just do it one way. I'm going to make it 3 to the power x. My base to x is 81. Well, 81, I'm getting used to seeing that as 3 to the power 4. And so x is 4. And so this is equal to 4. Similarly here, I know this is base 10. I'm going to call this x. So 10 to the x is equal to 1. Ooh. Well, I know that anything to the power of 0 is 1, and so x is equal to 0. I'm going to check this one out with my calculator. I have log of 1, and that equals 0. Super. And finally, this last one, I'm going to go 64 to the x is equal to 4. Well, I have 4 here. I could take 64 and write in terms of 4. This is 4 cubed, so the power of x is equal to 4 to the 1. Well, this is 4 to the 3x is equal to 4 to the 1. Well, 3x is equal to 1, and so x is equal to 1/3. And so if I try this with my calculator, if I go math, if I go to log base, my base is 64, and I want it to 4, and I get 0.333, which is 1/3. And finally, solving for x in these equations here. When we want to solve for x, I just rewrite the exponential form. I'm going to go 4 to the power 2, switch forms, is equal to x. Well, then x is simply 16. In this case, I know there's a 10 here, so it's 10 to the power 0 is equal to x. So 1 is equal to x. And finally, I have 8 to the exponent of 1/3 is equal to x. Well, now I need to work on my exponents here. I know that the negative puts it down low. And the 1/3 is the same as saying the cube root of 8, which here is 2. So x is equal to 1/2. All right, so there are some examples for you. They don't take long, but this step, converting back and forth between logarithms and exponentials, is a really important one to get a grasp of. Good luck.